Hi, I'm Alex McDermott, and this is my Introduction to Windows Server 2012 series, the Introduction to Hyper-V, and this is some of the material for Microsoft Exam 7410. Now, this is the third section of that exam on configuring Hyper-V, and it's worth 17% of that exam. And this is an overview of Hyper-V, and you can see it says create and configure virtual machine settings with some objectives, create and configure virtual machine storage with some objectives, and create and configure virtual networks. Really, what this is discussing is everything that you can do with physical hardware, you can do within Hyper-V. So if you wanted to, there is a Cisco Nexus virtual router that you can install that would allow you to connect between different virtual networks and physical networks. And if you wanted to, you could pull down rules from some master server, and it would do all the appropriate items that you would like that to do. So first, let's discuss really what makes a good Hyper-V host. In a lab environment, it's a little bit different than a production environment. I found, for me, I initially did a 1 terabyte hard drive, about 7,200 RPM, and once I got more than a few virtual machines on it, it got remarkably slow, and the slowness was in the disk subsystem. So I purchased another SSD drive, or I should say a first SSD drive, and did a reconfiguration of my lab workstation. I would say still go with 4 or more cores for your CPU, because when you're doing the initial installation of machines for a lab, it takes a while. I would recommend getting more than 16 gig of memory. I have about probably $700 now, but some of the materials have gone down in price, so you can probably do it for less. Where I have a 6-core AMD processor with 16 gig of memory, one solid state drive, about 200 gig, and 1 terabyte hard drive. So the machines I'm currently working on, they work reasonably well from the SSD. It's about 10 times faster than a hard disk drive, and it will be more than sufficient for running the material for at least the first 2 Microsoft exams in the MCSA series. So first, I'm not going to just take this in the order that Microsoft suggested, because I think the networks are probably more important. And you can see it says, configure Hyper-V switches, optimize network performance, MAC addresses, network isolation, synthetic and legacy network adapters. So a virtual switch is just that. It's a virtual switch. It doesn't have to be connected to an uplink port, which would be one of the network cards on your Hyper-V server. Optimizing network performance is about configuring minimums and maximums on bandwidth use by various virtual machines. Configuring MAC addresses for the virtual NICs that you happen to have. Network isolation could be VLANs, or it could be just setting everything to be on a private internal network to the Hyper-V machine. And then you have synthetic and legacy virtual network adapters, which are the synthetic ones are the current ones, and the legacy ones let you do boot from the network. All right, so let's discuss networking. We've got to implement Hyper-V network virtualization with virtual switches, optimize network performance, configure MAC addresses, configure network isolation, consider synthetic and legacy network adapters. With that said, let's go look at our Hyper-V server. In the Hyper-V manager, you'll see that I've connected to a Hyper-V machine called HV, and on the right side you can new virtual machine, hard disk, or floppy disk, import Hyper-V settings, and the virtual switch manager and the virtual SAN manager. So if you go to the virtual switch manager, when you set up Hyper-V initially, it asks you to set up a network. I did not do that, but I have 3 networks here. And you can see LabNet 1 is not connected to any network. It's private to things within the machine. Internal network is functionally the same as far as I can tell. And you have the option for VLAN tagging with a VLAN number. I've also got a DMZ, which is connected to my single network adapter on this machine. And I've got the checkbox to allow the operating system management to share this adapter, which would cause me problems otherwise because I wouldn't be able to reach it, since I'm now using RDP to connect. And I have another internal network called Lab2, which is a private network. And it's a bit unfortunate. There doesn't seem to be a way to say where these are really connected to as a group. But you can see this machine called TA is on the internal private network called LabNet1, as is this machine and this machine. I have these other machines here which are connected to Lab2, and Lab2.2 is a little interesting, as it says it's connected to DMZ, and it's also connected to Lab2. So this server is actually running direct access and running that between the Lab2 network here and the DMZ network. Now, when you're discussing these machines, a lot of things you have to do while you're off, but you have to be able to add synthetic and legacy adapters, which are really just this network adapter here and this legacy network adapter here. And if you read the text, the network adapter requires drivers that are installed when you install integration services to the guest operating system. Use a legacy network adapter to perform a network-based installation of the guest operating system, or when integration services are not installed in the guest operating system. Excuse me. The short version of that is, if you're using Windows deployment services, or Ghost over the network, or some other TFTP network rollout of your operating system, you're going to want the legacy network adapter. When you click on that, you see you've got the option for VLAN tagging within the switch. And optimizing network performance is really talking about enabling bandwidth. So if you have a heavily used Hyper-V host, and you have something like 30 virtual machines on it, which you could do under Windows 2003 with something like, I've had 20 Citrix servers running on one 4-core host with a very large number of network cards, because you might have one unit that's sent out one network and another unit sent out to another subnet, and a third unit sent out to another subnet, and with redundancy. Now, NIC teaming and NPIO can alleviate issues, but you might want to say that a given virtual machine is limited to a certain bandwidth. If you've got constraints, you might want to say a few hundred megabits per second. If you have a gigabit card, if you have a 10 gigabit card that you're running everything through, you'll want to adjust that appropriately. And it's also important that you have the minimum bandwidth, so you can say that whatever happens, there's always going to be this amount of connectivity. So if you're measuring the average bandwidth on a domain controller, that would be something that you would configure. Additionally, you can adjust the MAC address on the network adapters, and I'm looking for that. It's in here somewhere. You're going to have to look it up. Hardware acceleration, no. Advanced features, yes, there we go. So you could say, I want a static MAC address. DHCP guard basically checks to see if the DHCP server on the network is authorized within Active Directory. Ditto, router guard, and port mirroring is something that would let traffic from one virtual machine be copied to another virtual machine, and obviously you can do NIC teaming within the guest operating system. So that's really the virtual networks networking portion of this. You have to know what all of these things are and what they do, but really you've got your basic network situation, and it lets you create virtual networks for your lab machines. In my case, I have all of these machines running in the lab on a private network. I have one Windows server doing NAT translation and direct access, which allows me to run sus and other updates that might provide a little bit of stability to the system. That's the basic overview of virtual networking. We covered virtual switches, which are just like physical switches, with the VLAN tagging, so they're slightly smart switches. You can optimize network performance by setting bandwidth minimums and maximums for virtual machines. If you need a specific MAC address, you can configure that. You can configure network isolation to be private or public, and there's actually a facility to let you stretch networks across different IP networks using some advanced features in here, which I'm not going to cover. And the synthetic and legacy network adapters are merely a question of whether you're going to boot from the LAN or not, or whether you're going to use the Microsoft integration services for Hyper-V, which are some tools and drivers for Hyper-V machines. Next, we have virtual machine settings, which are configuring dynamic memory. When the machine starts up, how much memory does it get? Does the Hyper-V server then monitor it to figure out how much memory it actually needs? Smart paging lets you reboot a running server when there is physically not enough memory for the amount of memory that's been allocated to all of the virtual machines. Resource metering I'm not going to cover because it's PowerShell and it's not quite a standard item, and the guest integration services, which are Microsoft drivers and applications to allow Hyper-V to monitor machines better. Alright, so let's discuss virtual machine settings in Hyper-V. You saw a few of these in the settings for the network adapter, that you could choose a VLAN ID or change the MAC address. However, you also need to be able to add and remove and modify hard drives. It should be pretty simple. Say I want a new virtual hard disk, or I want to specify to a path to a hard disk that already exists if you had a server crash. VHD and VHDX refer to really the size and recoverability. VHDX is the new format for virtual hard disks, and it has some recoverability features in addition to the ability to go up to 64 terabytes, whereas the VHDs were limited to just under 2 terabytes. So when you create the disks, you can have the option of fixed or dynamically expanding or differencing, and you can put them where you want. So this is for lab 2-3, well, lab 2-3 is wrong, but that's the name I've called this machine. It's the third server in what I'm calling lab 2. And you can see here on my computer, I have a local C drive, a volume called fast vmvol, and a volume called slow d1. And you can see this is shared. This one is encrypted, and I'm going to go to slow d1, which is technically a slow d1 is an encrypted hard disk drive. I'm going to create let's go with 127. It's dynamically expanding. I'm over provisioning this disk, but it probably won't be an issue. And we can discuss whether this machine is going to be dynamic memory. Or I can say the minimum memory that it's got and the maximum memory that it has. Or you can turn off dynamic memory if I wanted it to be a set size. And so this can start at some size. And how important is it that this gets actual memory from the system versus other machines? Let's slide this back and forth. Smart paging is from, I believe, the Hyper-V settings. I actually don't see smart paging. But smart paging is to allow this machine to restart when there is an issue. So if your machine goes up or down and needs to restart, and the machine's, there we go, smart paging. Where do you page? And there's not enough physical memory to allocate to this machine for the amount of memory it needs for startup. The Hyper-V server will create a page file that allows this machine to restart however slowly, and then when it comes up, hopefully there's enough memory for its physical allocation with dynamic memory. If you're not using dynamic memory and you aren't over provisioning your machines, it's not really an issue. And I'm going to skip resource metering. I recommend you look at it. There's a PowerShell script to enable it and to configure it. Really, everything's supposed to be being done from PowerShell these days, or using the Server Manager remote server administration tools against a group of servers. So if I believe this is the machine that I wish to run, connect, file, settings. You see this machine has two hard drives. One is on the F drive, one is on the E drive. We're going to start this puppy up. And you'll see the C drive is on the SSD drive, and it's relatively fast to come up. Now, there are a few actions that can be done. insert integration services setup disk. This is functionally a set of drivers that are optimized for Hyper-V, plus some services integrations to allow the hypervisor to use VSS to back up machines, and so forth. So here's my server. It's called lab 2-3. It's in this lab. You go action, insert integration services disk. That should have come up here as do something. There we go. Install Hyper-V integration services. And the current version is the current version. So if you install it from Server 2012 on Hyper-V 2012, you get it. So let's close that and go to lab 2.3, settings, integration services. Operating system shutdown. Oops, let's turn that back on. That lets you shut it down nicely from the console. Time synchronization synchronizes the client machine against the host. If your host goes out of whack and you've got this selected, all of your servers. Heartbeat allows the host machine to check to see whether the client is up and running. And backup is really the VSS provider for Windows integrated backup. And that covers dynamic memory, smart paging, resource metering, and guest integration services. So finally, we have virtual machine storage, which are VHD files and VHDX files. VHDs can go over to 2040 gig, and VHDX can have up to 64 terabytes. Differencing drives are something that allows you to make a golden image and then create modified machines off of that. It's sort of similar to deduplication, except for it starts out with knowing that you need the deduplication. You make the OS disk with whatever applications you want, and then you roll out machines from that, which only have the differences between the golden image and the final machines. Modifying virtual hard drives. Pass-through disks allow you to have direct access to physical disk drives from a virtual machine. Snapshots, and I'm going to skip the virtual fiber channel adapter because I'm assuming that you don't have the ability within your test lab. All right, let's talk about virtual machine storage. You have two options within the Microsoft realm, which are the VHD format and the VHDX format. The VHD format is the older version, and the VHDX is the newer version and has some capabilities that the older version doesn't have. Now, if you go to disk management, you can do things like create a VHD, I believe, or attach a VHD, which will let you mount physically running VHDs. Additionally, when you do the add role or feature, for a machine, you can install a role or a feature to a virtual hard disk. So I could go to E, Hyper-V, DA, virtual hard disks. Oops, I think I moved this out of here. Well, I could use this machine, assuming it wasn't running, and install a feature just like you would to a normal machine. Differencing drives, I'm going to leave for an example for yourself. It requires PowerShell. The idea is if you are running VDI, you want to have one golden image of, say, a Windows client. And it needs to be modified by different people because you're using VDI, because you've got these power users who make some kind of configuration change and reboot their machine all the time. And it gives you the golden image that has Windows, patches, Office, other standard applications that your company has. And then to make a difference between that and any specific image, there is a Delta file or a difference drive that has things like the computer name got changed when it got joined to the domain, the random application that some developer needs was installed. So that's not particularly difficult. So in Hyper-V Manager, you can click settings on these things. And when you're talking about the drive, you can do something like edit the drive. So you can convert it from the new virtual hard disk if you wanted to, with a different type of format. You can expand it, you can shrink it. So I don't really want to do that, but you should examine that. Pass-through disks are a little bit different. They assume that the disk has not been brought online within the Hyper-V host and allow you to pass the disk directly through to a Hyper-V client. This might be something like an iSCSI situation, although I think you would do that directly from inside the machine, or if you had really a virtualized machine to simplify recovery, that you passed through the virtual hard drive with data for faster access. So maybe you had an OS drive on a little tiny mirror and a big data drive. Your OS drive for the Hyper-V machine would have the configuration files and maybe the initial boot up for your Hyper-V machine. And then your large data store would be handed directly through to your virtual machine. You can run that for an exercise in VMware more easily than in Hyper-V because it doesn't show the disks as virtualized, but that requires some modifications to VMware. Snapshots are fairly simple. Snapshot. I have a snapshot. I could turn this machine on. So here's 2-3. I can take a snapshot. And when I go to 2-3, connect. I have no idea what I was searching for a moment ago. Let's say I want to install something on this machine, but I want to bring it back later for a demo. So I'm going to add a roll-in feature, do something, then I can roll back to before this happened, which is really quite useful if you find that you have a patches you want to install. So maybe I want to patch this server. Take a snapshot of it. And if I need to, I can roll back to a snapshot, or I can apply a snapshot. So if I hit this apply button here, I would go back to this initial snapshot from 2 minutes ago, and it would be a little funny, and it would run. You see here is back where I was with the whatever I'd been searching for before. For the final thing, I don't expect you've got the ability to deal with it, but you can add a virtual fiber channel that allows your virtual machines to connect to a real fiber channel adapter and run through to whatever your fiber channel mask allows you to connect to the SAN. So that's it for virtual machine storage. And there'll be a little bit more review, and that's it. All right, so that's the sum and total of the information specified in this topic for Hyper-V, which is creating, configuring virtual machine settings, storage, and virtual networks. Everything you can do within an actual virtual machine, you can do within a real virtual machine. But there's a little bit more, which boils down to a few items. You can now snapshot ADCs. VMGen ID, probably not the correct term. The BIOS creates an ID number when it's snapshotted or copied. That means that when you turn on an Active Directory controller now, that it will come up, recognize that it's a copy, and it will ask for a full replication of everything in its relative ID pool. And in fact, it will throw away its existing relative ID pool, ask for a new set, and ask for a full replication of everything since that RID pool was handed out. You can clone domain controllers because the gen ID will allow this to happen. And you can do live migration without anything shared between two Hyper-V hosts. They don't even have to be in the same cluster. If you're in a failover cluster, you will have to take the machine out of the failover cluster, then copy it to the destination machine and possibly put it in a failover cluster there. Now you can also have failover clusters using SMB3 using only one file share. So that's really it for the Hyper-V configuration. And I'd like to make a note that the live migration also allows you to move only the virtual disk files for a machine. So in my case of this server, if you look at the settings, you'll find that I've got one of these disks is on drive E, which is an SSD controller, and one of these is on drive F, which is a hard disk drive. If you had SAN storage and local storage, that would also take care of it. And you should also be aware of replication, which I don't have listed here, and it doesn't seem to be one of the topics, but you should definitely test that out. So you can make a copy of a machine, have the VSS, you can have the two servers replicate the same Hyper-V machine. They will synchronize the data. If you set VSS up to do snapshots of the data within the machine before the replication sync between the two Hyper-V servers, that will make sure that everything runs properly from the replicated copy, and you can replicate them across multiple networks. That's it for this video, and I hope it was useful.